Hi all. How many we will be this morning? Do you know?
Hello. Hi, Lawrence.
Hi. Good morning.
Morning. We don't know exactly how many will be, but let's hope Silly and Edgar will join with us.
Mm-hmm.
Yeah,
Okay.
just so maybe you can wait for maybe 2 to 5 minutes.
No problem for that. Okay. Good morning to everyone. Can I start? I was waiting for Edgar and for I've seen that someone else is disappeared from the call. Should I start? In the meanwhile, we have the recording, so maybe the first part can be recovered somehow. Anyway, we will go a little bit slower today because we can do exercises and so on, so it will be a little more easy to follow. Can I start? Oh, I was muted. No,
Yeah,
okay.
sure.
Yeah, okay.
I hope you are doing some recapping or kind of review of the yesterday lecture. Then that is it. Are you doing that?
I'm recording. Yes, I'm recording this presentation. It was the question, isn't it?
No, I meant that are you beginning with reviewing what we have studied yesterday, or
Yes, sure. So
so
they
you can
can join in the
continue
meanwhile.
because
Yes.
our fellow maybe while you are doing that they will join, so you can do that.
Okay. Okay. Yesterday we have seen the first part of the training explaining essentially the front-end technologies that we have behind MapStore. We explained the syntax of ECMAScript new versions from 2015 until now that has been introduced and are often used are very used in MapStore. Classes, arrow functions, const, let variable declarations, optional chaining, nullish queries, spread, but also spread.
Lorenzo, sorry.
Yes.
Can you share your screen, please?
Yes, sure. Sorry, I forgot it completely. Which screen are you seeing? This one, isn't it? The slides, isn't it?
Perfect.
Okay.
Yeah.
I was saying we have seen the ECMAScript improvements that and new features introduced from 2015 until now. So classes, arrow functions, const and let variable declarations, optional chaining, nullish coalish, but and also spread operator that is used a lot, and the structuring used a lot too. And ECMAScript default REST operators that is similar to the spread, and array map filter and reduce new functions, promises that are very important for the communication between the MapStore and the server. Let me admit the other ones and show and reshare my screen. Okay, and we have seen promises that are very important for communication with the server. Then I introduced React and Flux architecture. So the implementation of the Flux architecture we are using, so that is Redux. We have seen the concept of user actions, and quickly I've seen what is a selector in general, what is the loop involved in the evolution of the user interface and the state of the application, and how they fit together to create the final application. Okay. Then, after introducing React and Redux, that are essentially the view part and the state of the application container, we introduced the Redux middleware yesterday to do async side effects, basically, that are, because all this flow to update the state, update the view, and trigger an action that updates the state, updates the view, and so on, is synchronous, basically, at least in the Redux implementation. We have some, in order to do some AJAX request or some asynchronous things in general, or other side effects like modify use some browsers, the browser sees some other things apart from this continuous flow, can be implemented by using a middleware that can be attached to the to Redux, in order to, for instance, do asynchronous request, and then we see the middleware, the Thunk middleware, and then we have seen an example of how to do a request to a server and get a response and trigger an action to update the state with the response. This is an example Thunk that does this, and at the end of the meeting, I introduced a library that we use in MapStore, that is Redux Observable, that allows to do asynchronous flows, but without the limitation that Thunk has, like intercepting actions during these asynchronous requests, allow to the cancellation of the requests, or cancellation of complex data flows, and in general. So I explained with a dedicated presentation this library that is pretty new, and I explained the concept of observables, and with this, that is an object with basically these three handlers. But in MapStore we don't use these handlers directly, because it's a little hard to do. But instead we use the RxJS library that is that provides a lot of operators that allow to create and parse these streams of event that are basically what the observable representation is, and manipulate the events that flows inside these streams to filter, to create new streams or new streams of event beginning from events received, and so on. There are some complex operations here and there that allow to manipulate the events coming from the user interface, or whatever application you want in general for the library. And filter, the bounds, for instance, is another example that can be explained to avoid to emit too many events in a time span, to emit only the last one, for instance. It's useful for continuous typing. If you search while typing, you don't want to search all the keys that has been typed, but only the last one the last string, the last updated string. If you, for instance, this is the typical example. If a tool searches while typing, I don't want to search on every single character typed, but I want to search only at the end of the writing, and the bouncing is this operation is provided by many libraries. For instance, Lodash has the bounce function for it, and also one of the operators in Redux is the bounce, for instance. And there are many operators. They are reachable from this link. We are using the version 5 of the library. There is a version 6 and a version 7 going to be developed, going to be released for Redux Observable. And we didn't migrate it yet. Anyway, if you open directly the site, you will be directed to the documentation of the new version that has a lot of syntax changes. So pay attention to use the proper link. Here we have okay, this one. I can find the documentation somewhere. They changed something in the documentation too. Let me find out. Okay. I don't have the link of the new one, but it is this one, yes. More than, let me share my screen again. We have here we have a different syntax, a little different. So pay attention to follow this link. I'll give you anyway. It's provided by the documentation, and as you can see here there is some information about the version 6 and what changed. Essentially, they changed from object from this dot notation. They move it to a more functional notation. But anyway, all the concepts are the same. Only the syntax of how to write observable changes. We will migrate in the future. There is a compatibility library here in order to start developing with a new language, but we didn't introduce it yet. So the link is this for the moment to get the documentation for our purposes. Then after introducing observables, I introduced Redux Observable. That is the library that we use, the middleware for Redux that we use. That is simply a library, a middleware that allow to create some functions called epic that has as argument first argument the action stream, the stream of actions coming from the Redux store. So it will emit all the actions emitted by the system, and it will return another observable with the actions that the epic want to emit. So for this is very useful because you can intercept some actions from the system in general, use some fake actions that doesn't modify the state, for instance, and only trigger an epic that trigger, for instance, some changes on the some changes on the that trigger, for instance, a request on the server, and then emit the new actions with the updated state that updates the state with the results, for instance. Or anyway, reacts to any event with another actions or many actions as you want. And you can create subflows that intercept actions starting, for instance, a subflow and intercepting, for instance, if you want to start listen for clicks on the map for a particular event, you can have a button, for instance, that tells the application that that is in edit mode. You
Hello.
click. Hello.
Lorenzo, can you tell us? Keep on sharing your screen, please.
Okay, I forgot it again.
Yeah, I was asking
Yes,
regarding,
yes, please.
regarding the delay. What
Yes.
is it all about?
Sorry?
A delay within that algorithm that you was displaying there.
Yes, I'm displaying what we did yesterday, more or less.
That's one. That's like the delay part.
Yes.
Why is it important to have that delay part within that?
Yeah, this is only an example. For instance, here we have an immediate operation. We have some operators, for instance, to delay some. It's possible to, for instance, for a game, for if you are doing an operation that needs a delay, you can delay the request. Or if you have to wait 3 or 4 seconds because before to before to reject a request, for instance, you can use a delay. You can emit another actions that that cancel the request if it's taking too much. There are many useful. There are many use cases that you can use the delay operator. Basically, these intercept this first row, intercept and filters the action coming from the Redux infrastructure. Can be another epic, can have emitted it, or a click on the mouse and the dispatch function inside the connect can dispatch this. Anyway, once it has been intercepted, this event flows inside the epic inside the stream, and you can delay this event, and map2 allow to react with an event with another event. Let's see a little bit. Let's see this example more. I remember that there was yes a useful site. I share it in the chat. This site is very useful to understand the operators, because you can move the events coming from, for instance, the from we have seen creates three for instance, creates 3 events. This is the delay of time, and so this is there are many examples for it. This is the creation as observable. Then for instance, we have seen the filter that, as you can see, filters events, only events that are more than 10. And here you can move these bolts to understand what happens in time. And I don't know if a delay is here. Yes, it's here. Basically, delay does this. Takes the stream, you apply the method, and the delays of total amount of milliseconds later the event. As you can see, if I send the events a little bit later, I will have the effect of having another stream applying this delay with that emits these events a little later. We can see also the flat map, the switch map we have seen. Switch map, as I said yesterday, was an operator that on every event cancels that creates a stream and flatten all the events emitted by the stream created in the resulting observable. And if it receives a new observable, a new event from the first observable, it stops emitting the events from the previous stream and creates a new one. This helps you to understand that if I move, I emit an event before this stream, for instance, gets the observable one, and then emits a string that concatenates that takes another observable here. I have another observable here, for instance, and I concatenate I join the string coming from the first event. I emit 3.3 numbers in sequence, and I join the two strings. As you can see, as well as this is the string created by the observable. This is the original string that receives the events. Is that clear? Then you can see that the switch map, if receives another event before the internal stream is completed, stops emitting the original events and starts emitting new events. Starting from the new event coming from this input stream. Okay, you can play with this tool that is very fun in order to understand maybe all the operators. Anyway, we will today we will try them. So the important things that you have to take into consideration is that Epix receives actions from the systems and emits new actions on demand, what you want, by using the stream, the RxJS operators and RxJS utilities to parse the flows. Is that clear? Did I reply your question? I went a little bit further, but I think I hope I replied your question.
Yeah, I understood you.
Yeah. Okay.
Thank you.
Okay. Then here, more or less, as I said, yes, there are many operators, but these are the most used. Filter, we have seen it. Map, more or less, is similar to the map for arrays, and there are many of them. We will see a couple of them while developing the plugin. Okay. I want to show you this in animation just as a summary of what you have learned about React Redux. It is a little hard to follow, but if we take a look at it a couple of times, we can understand it. Basically, we start from the view. For instance, from the view, the user clicks somewhere now, and it emits an event. The event is translated in an action. The action somehow is it's too fast anyway. Let's restart. The event is emitted by it emits an action. It received from the store. For the moment, let's ignore this part. and only follow the big cycle. Event, translated with an action, dispatched to the store, reducer and state has been updated, and the state is updated to the view. And once again, event, action, dispatched to the store, state update, state propagated to the view, and so the view is updated in this case. Now let's see the last part. The action have a side effect. For instance, we do a request to the server that emits another action, and it is propagated to the reducer, and it updates the state again. Let's see the full cycle again, last time. From here, from now. A user clicks, for instance, an action is emitted, a request is sent to the server. In the meanwhile, the states update, the request response, and the states updates again, and the view is updated, and so on. This is the more or less the continuous flow that happens behind the Redux React Redux application. This is very useful to summarize somehow all the events and all the changes happening inside the application. Is it clear? It's a little bit hard to follow in startup, but if you take a look a couple of times to the animation, it should be useful. Can I go further, or it's not clear? Do we have some questions? I can go to the MapStore section. Can I go?
Yeah, I think let's go.
Okay. If there are no questions, I can go further. So let's begin with today's lesson. Okay. Today we are going to talk about MapStore, finally, and eventually, and we will talk about the architecture of MapStore in general, because it is a product, first of all, and when you develop, usually you will have a backend in MapStore, but you can also have, you can take the same informations to understand also the GeoNode implementation. And so after the architecture has been is clear, we can pass to how to build MapStore, and in order to run it and deploy it, and how to develop it. These steps helps you to start understanding the internal structure, and then well understand where are the important points where you have to focus on when you develop. Okay, as we said in the previous lesson, it's MapStore uses JavaScript, React, and Redux. It's 99%, 90% JavaScript, and the part used by GeoNode is only the JavaScript part. And it provides basically a framework to develop your own plugin and to include them. In general, it provides a plugin system that allows to develop separated units that can be included and injected into the user interface in order to add to the application your own parts, and of course it provides a lot of predefined tools from common mapping functionalities and for sharing maps and everything we have seen in the product yesterday. Other than the plugin system that allow to develop single units that can be included in MapStore. It provides also standard app and standard store that are simple entry point in order to avoid to create Redux store. There is a new unique Redux store and a unique application. You can plug in your plugins and your parts. So you don't have to care about the structure, but only develop your own reducer for your own piece of state that you're interested to, or you can get state from other components if needed. And it provides the functionalities to develop your application. You can write your own application, your own UI, your own reducers, your own actions, and join them together into a plugin to put inside MapStore. MapStore is also a framework to create other than the product that can be installed and deployed on a server. It is also a framework, as I said, and it has a project creation system that allows to create some sort of clone of MapStore that uses almost everything from MapStore and allow you to isolate your components and for your custom application. So you can use MapStore as the base to develop your own application, adding only your plugins and create a separate application that uses MapStore, but it is not the final product. This will be more clear when we will see how to create projects and so on. Last but not least, mapping library agnostic. So it uses independently open layers, leaflet, Cesium, and we are going to evaluate all the mapping libraries. For instance, we in the future, if some of that libraries disappears or is not used or maintained anymore, MapStore can still live without it and continue using other mapping libraries that are that are used in that period. Basically, as I said, this is more or less a schema of what we have. We have some all the plugins introduce in the application some reducers and some actions and some components. Here the division is between smart components and dumb components. Dumb components are components that are not connected to the state. Smart are the ones that are connected, so that they use the function connect. We studied it yesterday, but anyway, we will use it so we can refresh the memory of that. And this is the cycle we have seen a couple of times. And for the mapping library, a component implements leaflet or the implementation for leaflet or open layers. So you don't have to care about open layers or leaflet, but you can control the map from the properties as all the other components in the application. You can use the same programming paradigm for every component and even include the map. And sometimes you have a communication with the backend also, and because it is a single page application, basically all the interactions comes from are usually applied you doing AJAX requests, so asynchronous requests to the backend. Now we are talking about the backend. Let's clarify what is the backend for MapStore. Okay, in GeoNode, backend is GeoNode. In MapStore, there is a Java application written in Spring MVC and using and other technologies coming from all other projects. And they are typically they are three main parts. The MapStore backend that is included, that provides base settings, base services, and it has been introduced very recently. This part in the last release that has been released yesterday. So this part is very new and contains useful backend service for data directory, for extensions support, and so on. New features of the new release. And before this, the backend of MapStore was only made of two parts: JavaStore. JavaStore, that is the main part, and it is the backend part that provides users and authentication system. This is one of the core parts of JavaStore, and the other part is the resources access system. Here in MapStore, you can see that you can log in, and login is provided by JavaStore as well, and you can share resources like maps or dashboards and stories. You can share them with user groups and so on. And these resources handling, managing system on the database is managed by JavaStore. This is the role of JavaStore. Then HTTP proxy is an utility to support some cross-origin requests in order to allow MapStore to query also other services other than and avoid somehow with the security included the cross-origin limit, the cross-origin, sorry, the same origin policy of the browser. It's a very specific application for that purpose. So we have the front end. Here the front end collapsed in this rectangle, and we can see the backend detail. So we have JavaStore that provides users and resources and rules to access to that resources, and they are stored on the database. Then HTTP proxy that allow to access to external web services. Then this is the third part, essentially, that allows to the MapStore part that allows to access to provide some features coming from the latest release. Anyway, if you will develop on your node, you will not be so interested on that, because if you're developing on your node, they are not yet included, and they are not part of the actual implementation in Genode. But only support some useful features. If you want, I can explain it. I've shown you this context API. Basically, in this context API, you are able to import plugins and install them in the application. This is one of the features provided by the new backend part, specific of MapStore. You can install plugin in an existing instance of MapStore, and this initial support or installation of plugins is provided by this backend service. Okay. So you have a front end and a back end, and how the application is built together to provide front end and back end in a final package. Typically, MapStore is as a product is deployed in a WAR file, so is an web archive file. Is a zip file basically that contains an application for Java servlet containers. Can be deployed on Tomcat or on other servlet container. The most famous is Tomcat, and we use it a lot. But anyway, it should be there are other existing, and you should be able to deploy it also on them. To understand how we create the final Word file, we have to talk about some libraries as I said, there is a JavaScript fatigue, known as JavaScript fatigue, that there is a problem of developing applications in these years because we have many libraries behind and big ecosystems of libraries behind JavaScript. Every application uses its own, and so we attempted to use as less libraries as possible. But anyway, there are a lot yet, but they are they are not always the most common, but almost always the most common. First of all, and other than this, we have the Java part. So let's begin from the JavaScript part. MapStore is an application that is built by using a Webpack, that is a module bundler. It's an application and provides also the dev server where you can develop the application, and you can find some information about it here on its own site. And basically it takes all the JavaScript files in the applications and creates bundles. So you can get a lot of modules in your application. MapStore has a very big this is MapStore. MapStore has a lot of files, as you can see, and they are bundled all together in single files that can be downloaded. It's useful to provide a single or some bundles that can be downloaded on demand anyway. A set of limited elements that can be downloaded in your application. So this tool allow to get all the files from MapStore, all the files for actions, and etc., and compact them into small bundles, and even compress them in order to have static assets that can be used in a web application. So Webpack takes these. Let me close some tabs in order to not confuse. Takes these files from our application and from npm, that is a dependent JavaScript dependency manager. You probably have seen it if you're developing in JavaScript. Allow you to manage your dependencies basically and download them. So here you have a package.json file, typically in an application that uses npm, that provides all the dependencies. These are for dev, these are for MapStore in general. These are the dependencies. They are downloaded in a directory called node modules, where you run npm install. When you run npm install, that is the first command that you have to run, you will see a directory called node modules in your root directory that contains all the libraries here. And Webpack will take the files from a typical file in MapStore has some includes some imports on the beginning that imports some library. For instance, here I'm importing some commands from Lodash. Then also other includes from other libraries, and export something. Webpack gets all these import commands and from external libraries or from internal your own system, and put them together into a bundle, or one or more bundle depending on the configuration of Webpack, and to create a final application. And it uses Babel, that is probably included as a loader for Webpack. That is a library that allow you to translate ECMAScript 6, 7, 8 until 11 into a code that is understandable for all the browsers. Sometimes we say it is transpiled because it's not compiled, even if it's named like this. But sometimes we used to say transpile instead of compiling because it's translating in the same language. It's not compiling in machine language or another code like bytecode. Is for this reason someone says transpiling is instead of compiling. So basically we have seen Webpack that create bundles, getting libraries from npm and from in JavaScript, our own JavaScript file, and put them all together with the HTML files, less CSS files, and so on, using Babel to translate. Somehow it compresses also the things and the file to as much as possible, and it creates a dist directory. If you, when you compile, you will see npm. If I compile, everything will be this is not MapStore directory. All the JavaScript files are here in web client directory, and when you compile, you will see this directory. When you compile, that contains all these are the chunks, the files that are created, and these are chunks for smaller libraries loaded on demand. And the main bundle is called MapStore JS. That is a compressed file. I try to open it, but anyway, it's not so understandable because, as you can see, it has been compressed, compiled, reduced in size, and all the strings has been compressed as much as possible. So it's hard to read it. This is the final set of assets, so the set of JavaScript files, HTML files, less files for the front end. Apart from that, we use a Karma directory that does unit tests. Anyway, it is a test runner, nothing important for the explanation today. And the final Java application is created by Maven, that is a framework that allows to create a Java application, and that gets the Java part, so all the backend, just store, HTTP proxy configuration, etc., and put it together with the dist directory and create the final Word file that is that contains the application, the final application. Basically, all the index HTML are HTML files that can be used by a Java application, and they are included together with the JavaScript files here inside that, and together with that HTML part, JavaScript part, we have a backend services system that is included in this package, and it can be deployed inside of Tomcat, for instance. So, as I said, there is in MapStore there is a build.js scripts, build.sh script that allow you to run to create the final Word file, And there are some commands to execute tests, generate documentation, and so on. But the important part is this, basically, these three commands: npm install to download the npm dependencies, npm run compile that does this creation of the dist directory, and just a second. And at the end, the maven clean install operation. Maven install is sufficient. Cleans the previous created things anyway. Maven install is more than sufficient. That is more than and it downloads Java dependencies and build the final word with dist, and you can find the final file in web target directory. If I run build.js at the end, I will have, I already did it. I think you can find the target directory that is created by Maven, and here you can see the MapStore.war file that it can be deployed in Tomcat and used. This file can be deployed, as I said, in Tomcat. By default, it uses an H2 database. This is this configuration is not suggested on production because the H2 database has some problems, can be used only in test or single user purposes. So in the documentation, you can find the guide to connect your own database. PostgreSQL and Oracle are supported in order to have MapStore in production. And that's more or less that everything you need to know about installation of MapStore, only configuring the database and using it. There are some, in the documentation you can find also some other utilities to integrate to GeoServer, with GeoServer or with LDAP, of course in GeoNode. This is already present because GeoNode is already integrated with GeoServer. And the user system is the one of GeoNode, and it doesn't use the user system of MapStore. So I will not go too much deep into this, but if you want to download MapStore for instance, from GitHub, you can get the latest release, officially released yesterday. We created the bundle a couple of weeks ago. Anyway, the message, the email on the main list has been sent yesterday, and you can download store.org on your application, on your Tomcat, or download even the bundle, that an application that contains a Tomcat inside, so you can simply download that and run the script for setup, and it will start locally. Okay. Let me recover the point I was where. Okay. Last thing, but it's not important, is documented. By default, when you start this MapStore, you have two users, one admin user with password admin and a user with user named user with the password user. Questions for this part?
Hello, Lorenzo.
Hi.
Is there any documentation that we can get for how to install this MapStore in our machines, both production and development?
Yes, the documentation of MapStore has evolved a lot. DepStore, MapStore.readdocs.io is the main documentation, and here You can see the developer guide, quick setup and run. Sorry, developing, deploying. There is anyway here you can find the installation guide. I don't remember if it is user or I think it's developer guide requirements or installation. As you can see, it's simple. And databases here you can find database setup entry. On how to set up database. When you install the WAR, you can set up the database, and moreover, you can use even integrate to GeoCyber and another app. Anyway, the only thing that you have to do if you are a user, a person that want to install MapStore as it is simply to download it and run and install it in Tomcat. So deploying and move it in the web apps directory of Tomcat and start the Tomcat. This is the main operation you can do. Nothing different from other Java applications.
And that one can be development side, the one that they want to change me for the development. If I upload theirs to web apps and Tomcats.
Sorry, can you repeat?
I mean, that one you say that if I download from this one and put the web apps there and the Tomcats, I can use as a development side or just for production?
Just for production, yes. If you want to develop it, yes, I'm going to explain how to develop it in the next section. You can build it from development running build sh here. But first of all, let's start from the beginning. You open you get and you clone the repository of MapStore. Maybe this was not clear, and install and you download it in your doing git clone and your application. So git clone and the URL of the main MapStore repository. This is what I did here. I already did it here, and so this directory. Let me explain a little bit more, because this question is correct. It is very useful. Here in my project directory, I executed first of all git clone and the URL of the git repository. This allowed me. This creates a new directory called MapStore2, and here you can find it. There are a lot of directories here. Sorry, let me collapse them. This is, let me open it in Outlook so it's more clear for you. When I download MapStore, I have a new directory called MapStore2 here, and you have some directories that I will explain. Anyway, here, if you open the console from this directory, you can run build.sh, and it will create the final war in a web target directory. This, if you developed something and modified something, you can build your own version of MapStore, or you can, for instance, improve MapStore with some fixes and so on by doing when you build. Sorry, there is a lot of noise. Sorry, I have to mute someone. Okay. This is if you when you develop the. Let me share screen again. This is when you now I stopped the build because it takes a lot, but anyway, and this is when you build the MapStore as a product. Okay. Basically, when you want to, so this allows to create a final word with Java part together with MapStore part, with the front-end part. Now I will explain how to develop in both the places. So you can, after developing, you can build, of course, the final word and deploy somewhere. Anyway, you have an environment to, of course, test it locally and run it locally without deploying it in MapStore. Is it clear? I know that I have to explain a little bit something else.
Yeah, it's clear, I think, for the concept. Thank you.
Okay. And okay, now let's start to run the application in developer mode. Make sure to run after cloning and go and doing cd into the directory. Make sure to run npm install at least once at the beginning or when you update some dependencies in order to download all the dependencies. It can be done only once, as well as you don't update the dependencies is not required anymore. If you update MapStore from some dependencies may be changed. So when you get, I don't know if you are competent with Git, but to get updates from Git, you usually do a git pull command that gets all the, for instance, now for sure I have some updates, and if packages unchanged, typically dependencies changes and you have to run again npm install to download the latest dependencies. Anyway, I already run it. The changes I downloaded that has been probably developed today or yesterday on MapStore master branch are doesn't contain any changes to dependencies, so I can only start developing mode by running npm start. Npm start, we start the Webpack dev server that I introduced a little here. That provides, as I said, it creates the bundles, but provides also dev server to emulate these bundles and allow you to debug in not compressed mode. Webpack creates the bundles, unreadable bundles I've shown you, but when you develop, you want to read the code, of course, and so Webpack provides also a dev server that has been started running the command npm start. And in this mode, all the files included as libraries or as models are not too much modified. A little bit are modified because of performance issues, but anyway, they are still readable, and so you can use it to debug it. To debug the server. Once yes, now it's running, and you can find the application running on localhost 8081. So the application now is in debug mode, in the development mode. MapStore is running locally. The backend part is still using the dev server I've shown you sometimes. By default, MapStore uses this development server that is the backend part. It uses the backend part of the development server by default. Let's summarize because I introduced a lot of information, and so let's recap a little bit the points we followed, so we can continue on developing on developer parts. So let's summarize. Front-end, backend, MapStore. Front-end is a JavaScript application, single-page application. Backend is a Java application, as in in the product mode. They are built and put together using some libraries. The important ones are npm for dependencies in JavaScript, Webpack for bundling, and Maven to create the final war and put together the Java part with MapStore. As you can see, in order to run MapStore in development mode, you have to simply, in order to compile it, you have to simply run the build script. These are the important points of the script. But anyway, to build, you have to simply download, of course, the Git MapStore from Git and to go in the directory and run the build.sh script in order to build the final war. And in order to instead run in development mode, you have to run at least once npm install at the beginning, and then the only command that you have to run in order to start developing is npm start. This command will start the Webpack dev server in localhost 8081. Okay. This part runs only the backend, the front-end part. npm start runs only the front-end part, so only this part of the application is emulated by the Webpack dev server, only the part in blue. The part in red is still the part in red is used by default. MapStore uses this dev server to run the backend part. In order to run locally also the backend part, you can install MapStore War in your application in a Tomcat locally and run it. This is very simple. You can run the dev sorry, and you, as I said, Webpack the server uses the backend service, as I said, the dev backend service, and in order to use a local instance and run everything locally, you can simply download or build your own MapStore or locally and edit one file of configuration of Webpack dev server to point, instead of using a dev server, instead you can use your localhost application. Let's do it together. Now I have a Tomcat here somewhere. I think I have work programs, Apache Tomcat, web apps. Here I have already an instance installed of MapStore. So anyway, the only thing that you have to do is to copy a MapStore here and copy in the web app directory of you download Apache Tomcat, that is a package, and you extract it in a directory of your own. The Tomcat will contain these directories, basically these files. You can put simply the MapStore war created by the build.sh script into this directory. You can drop it in this directory. Then here you can open the terminal and run the script and start up Tomcat by running bin startup.sh. This will start Tomcat. By default, Tomcat runs on port localhost 8080. And here in the /MapStore, we will find MapStore running as well as its stars. It's going to start. There are some application in there. Anyway, yes, now it's starting. As you can see, now I have deployed MapStore war in my Tomcat, and so I have the default user and password. So admin to log in, and here I have an empty version of MapStore that I can use as backend. Here I can stop my Webpack dev server and change the configuration in order to point to my local MapStore backend services instead of using the dev.mapstore.geosolutions.it. To do this, you have to edit a file called build as in build directory. There is a file called buildconfig.js that contains all the configuration, and you have to change these entry points to change HTTP protocol because HTTPS locally is not. I didn't install any any certificate, so I can use simply HTTP and replace dev.mapstore.geosolutions.it with the address of my local instance of MapStore backend service, that is localhost 8080. So let's do it. Build.buildconfig.js. I open this file. At the end, we have some. Here we have all the configuration for the build. There are a lot, but you can concentrate on the dev server entry. There is a proxy that provides some targets, and you can replace all these strings with host 8080 and also replace HTTPS with HTTP. Also the proxy, I forgot this. Now, if I restart again, I usually run the commands from the integrated terminal of VS Code, Visual Studio Code. This is the ID I use, and this is an integrated terminal. So writing commands here is the same as writing commands here in the terminal. So npm start. Now I started the Webpack dev server to point, changing the configuration to point in my local instance of MapStore instead of the backend service that is the default. Instead of using dev.geosolutions.it, etc. Instead of using this, I'll use localhost 8080. Localhost 8080. MapStore. Now pay attention. Then when the build is finished here, when the dev server has started, you will see that instead of having this, now I refresh the page, and you will see that I'm connected to the local instance, so I will not have the maps coming from dev.mapstore.geosolutions.it. I don't have. Okay, now stop is started. So you will see that this now loads contents from localhost 8080, and so I can log in instead of using the password. I can use the local password admin, and I can start using the local backend part also. This was a difficult thing to do, but now you have a full set of backend and front end running locally. Usually when you develop on MapStore, 99% of the time you develop on the front-end side. So running the backend as locally as it is as a product is more than enough. So, okay, please tell me.
Can you change that language to English, maybe?
Yes, language of MapStore, you mean?
Yeah.
Yes, okay. Sometimes, yes, if I refresh, unfortunately, yes. Now I have,
That's good.
yes, now I have a clear instance of MapStore. Thank you. Please tell me if sometimes when I refresh it's not clear because the language is reached again in Italian because the browser default is in Italian. Let me try find out if I can change it from the settings. No. Okay, now if I restart the browser, now it should be in English. Let's try. There is a lot of suspense. Yes, now is the default language of my browser is in English, so it starts in English, and we don't have to care about it anymore.
Thank you very much for your effort.
Yeah.
Thank you.
Okay. I cannot change the language of the IDE so simply. I don't know how to do it. Anyway, I'll try to translate as much as possible when you see some menus here or something like that.
Worry not, worry not.
Okay, so summarizing the last part, then we can do a pause if you want. I can get again the okay. So, summarizing, now we are able to run the application in dev mode by using the backend locally and running the front end in dev server of Webpack. This is the important part. Now here in this mode, you're able to, for instance, let's create a new map just for instance. You're able to use the developer tools, and the sources are for instance, here I can put breakpoints here in the developer tools. You can open the developer tools by tools, developer tools, open sources here, and here you can type, for instance, ctrlp to find out the files you want to debug. For instance, I can intercept the reducer or the actions for search, action search. For instance, I can intercept when the action creator of text search change is called, and I can type search, and you see that I'm in the bug now, and I see all the text inserted, and I can go back to the call stack and understand where it has been called. This is the component, the search bar input component that called the action, and it has been dispatched by the framework, and then the action has been performed. So here I can even intercept the reducer part. Here I already I can use the reducers search, and there is already a breakpoint here. I can so go further, and I see that now the action has been intercepted by this reducer, and here you can see the old state of this reducer that has only the style, and you can see that the action received contains the search text, and the next state will be, I can execute this command, for instance, in the console, and see there you can debug everything and try to execute some code here and see. As you can do normal debugging, and you can see values of the variables and so on. And moreover, you can even run use the same the bug root flag here that I explained a little bit the last time, the previous lesson. And now you have another tab here called Redux with all the action triggered and all the state of the current state of the application. Here you can see every entry here is a reducer, is created by a reducer. This is the returned values of every reducer. This is the full state of the application. You can see this is collapsed, so you can expand. This is the full state of the application. As you can see, there is a reducer for layers that shows all the layers in the map. There is a reducer for map. I can find it. Where it is? Yes, here. Here there is also the history here. So as well as I change the history, the past array contains previous states. And here you can see the center of the map, the zoom, the max extent, and all the information of the state of the map. For instance, the resolutions and so on, the projection, the current projection, and the units of the map. So as well as I change position for the map, you see that I received a change zoom level action triggered that changed the new zoom level here. This caused a change in the map.best. As I said, there is an history here for the map, and in the new state, the zoom variable changed, and you can see all. You can see that now the full state has been changed. And for instance, I can change the position here, and you can see that the change map view is triggered. And if you see the present of the map, now the center has changed, and the bounding box too. So every action you trigger causes a state change, and this is accessible to every other tree, and so you can use this state and use this tool to debug and to understand what's happening to the state. Okay, if you want, we can take a break. If you want 5 minutes, or if you want a longer break, because yesterday we ran a lot, so we did only a 5 minutes break, but now we can have a 10-minute break. It's okay for you?
Yeah, it's okay, I think. 10
Yes.
minutes break.
So we can find out, we can restart from 20 past 11 in our time, but anyway, in 10 minutes. Okay?
Okay.
Okay, thank you. See you later.
Meeting is being recorded.
Okay, let's start again. First of all, questions. Are you there? First of all.
I am.
Okay. At least someone is there. Okay. Let's start with summarizing what we have learned before. We learned how to build a MapStore product with the main parts, that is the backend and the front end, made by the system of users and resources. The backend is, the front end is basically an application made with plugins and so on, and the backend is made by three parts: one specific, one for handling users and resources and permission on that, and then some additional services for specific purposes. Or another part is the printing tool and so on. There are some specific parts beside. Hmm?
Screen, yes.
Oh, yes. Sorry, I always forgot. Okay, now we can see it. Yes.
Yes, we can.
Okay. Thanks. Please remember me if I forget to share the screen. I see that today and even yesterday I did it a lot of time. Okay, so we say that MapStore is made of front-end part written in JavaScript with React Redux with a plugin system and an application that provides a framework that provides the tools to develop plugins independently. And the backend part is a Java application containing the system of users and resources and how to the permissions to access to them, and then some additional services for very specific parts. We learned how what are the tools involved in building a MapStore application. The MapStore, we learned that there is a JavaScript part that builds a dist directory where all the assets, all the static assets are compressed into small and more less in number and less in size files in a dist directory. That this directory, together with the HTML, etc., is included in in the Word file together with the Java backend by Maven. The first part is the first build part creates all the bundle, the static assets, and the final part creates the final Word file with Java backend and also with this index HTML and all the connected JavaScript inside. Then we learned how to install MapStore Word in a Tomcat. Simply download Tomcat or install Tomcat on your machine and put it in the in the web apps directory. I don't want to talk about how to set up the database because it's boring, but anyway, you can find this documentation online. We used this deploy in order to have a backend running locally for MapStore develop environment. We start the front end by running npm start, and this command allow to run MapStore with the JavaScript exploded, so you can debug it in localhost 8081 at localhost 8081. I explained how to configure the buildconfig.js in order to use local instance of MapStore as a backend. Let me restart sharing. we learned how to use this backend, the backend that we installed locally as the backend for the dev, for the development environment, and then I started explaining how to debug the locally. I explained how to put breakpoints in files. Now we will see more in detail the files in MapStore, so you can understand which files are present and which probably we will have to debug. And I also explained how to turn on the debug mode of Redux and how to check the action triggered in the Redux store and the changes, how to explore the history of the changes during the application execution. Okay. One note about this web while debugging, you will find you will not find the real file. If you look at this file, search reducers.search.js file, you will see that there are some requires. We will see they are more or less the same of imports. I will explain a little bit better later. Anyway, these are these imports information from other files, and here in the debug of the browser, in the debug tool of the browser, you will see some additional things or some strange replacement that Webpack does. And you will not always see the full exactly the same file you find in development. This is especially true for components. For instance, if you look for the search bar input, you will not see the if, and let's open it. Okay, I found you here. You can see some JSX, but here you will not see JSX, but you will see some. This is React.createElement. This is because Webpack have several ways to build the code for the bug and doing the mapping. In MapStore, we use this. This is configured in the same build config we have seen here, that tool. And in MapStore runs in eval mode. There are several ways that when you can set this variable. We choose eval because it's faster and generates a code that is almost it's even readable, but there are ways there are other settings for this setup that allow to have the code more similar to the initial one, but they are slower, and so it's hard to develop in that modes. We found out the eval mode was the faster in terms of build and rebuild the generate code while typing, while creating modifying the code, and it was for us the best compromise between performances and readability of the code in debug mode. You can change them if you have a supercomputer or something like that. You can try to change them in the way you want. I prefer to use eval because anyway I'm habituated to to look at the code for it, but you're not forced to use this way if you are not confident with it. Anyway, you will see that the build when you typically when you develop you change something here. You can add another attribute, for instance. Add here I added the dummy code, and as well as you save, you see that the compile starts automatically and it's almost immediately applied using eval. So you can it automatically refreshes, and so you will see your changes almost instantly. If you change that that parameter, it will be a lot slower. If you use, for instance, another setting that allow to use source maps and something like that, but it will be more readable. It's up to you if you want to change things and you and make the code in the debug more readable. Anyway, here I think it's an all readable to debug, because the only thing that you have to understand is if you have a JSX, it will be transformed into a create element, and the attributes are passed as an object. And if you understand this, you can read also this code in debug mode. So. We already did this. There is another note about debugging backend, but I don't think you are interested too, because you are more interested to the general part that doesn't include the backend. Anyway, you can set up. There are some guidelines online to use JPDA, that is the debugging system of Tomcat of Java, and set up the Tomcat to use this debug system. And you can use Eclipse, that is IDE for developing Java application, in order to connect to Tomcat in debug mode, and you can debug also the code of the backend. But as I said, just for instance, just to explain, in the backend part of MapStore is developed only by me and another person in the whole MapStore team. That is the core MapStore team is 10 persons. The people and only me and another maintain, and we don't do too much changes to that part. So just to explain that most of the work that you do on MapStore is on the front end side, and if you are interested to Geonode, it is only the backend is not used. So this is not important at all for you. Just a note if you want to fix, or if you want to enhance the backend, this is the way you can do it. Okay, so we can start exploring MapStore in order to understand how it's made, where are the pieces of the code we are interested to, and to start developing a plugin. If you take a look at the tree, there are in the root we have several files for build in the build directory. Let's and there's some files that are required by many tools like documentation by Travis, that are services for automatic testings and so on. you may be not interested for it at the beginning, and the only thing that you are interested to is the web directory. The web directory contains the POM XML, that is the Maven entry point that allow you to build the final application. And then the front-end part is in the client directory. So when you develop on the front end, you will work in the web client directory. Web instead, the other directory that is present in the web directory is src, that contains the, as I said, the backend of MapStore. This part. The other ones are included as external dependencies from Maven. This is the src directory contains the Java files only for this part. So if you develop on MapStore on client side, you will probably work with the web client directory. So let's concentrate on this directory. And the web client directory has an index HTML file that is used in debug mode. So I took the wrong one. There are some example that contains also index.html, but it's not the case. Index.html. Yeah, this one. This is almost empty. It has some. This is the style for the initial loading spinner. In order to show the spinner before the application is loaded. And then it includes some external libraries for instance, for leaflet or Cesium and so on, or CSS. And it includes, this is the spinner, and this is the style for the spinner, and this is the spinner. And then it simply includes the bundle dist MapStore 2, that is the main entry point here. As I said, the dev server of Webpack emulates these JavaScript entry points and use it to import all the unbundled files that you can search in the developer tools. So this script inclusion download the JavaScript file generated by Webpack dev server, and it includes all the files exploded in order to debug. When you deploy instead, you will have an index.js similar to this, but the bundle is a real file with all the files, with all the MapStore application compressed. And it will include also some small bundles here and there on demand, but the main entry point is a real file. Instead, in dev mode is emulated. The production file is created by Webpack using this index template. That is almost the same file, but here you cannot see this file because these templates are created only for only to one hash. When you build MapStore, in order to avoid caching problems, it a hashed version of the MapStore bundle, something like MapStore 2 dash and some a code of the hash, a unique code of the hash of the bundle in order to avoid caching problems. This difference between index and index template, we will remove them in the next versions of MapStore if possible. Anyway, this is basically a copy apart from this script tag that is not included because it's injected on build time, but it's almost the same. Anyway, you will find them if you do changes on this, you will have to do changes on also on this, at least as well as we unified it in the next version of MapStore. Apart from this detail, you have the index file that is the entry point of the application. Localhost 8081 is this doing it. Probably you know that doing calling index.html or not doing it is the same in the web application. It's implicit that you are accessing to index.html. So this is the main entry point. You will see other entry points that allows the usage of an embedded version that is a smaller bundle for embedded to embed in external applications, and the API bundle that allow you to to run the API version of MapStore. We will see it later. Maybe this is a part that is also explained in the Genode version, because Genode version is a customized version of the API. Anyway, we have an index HTML that is a base entry point. We have older entry points for smaller or different version of MapStore, but it's for the moment is only sufficient that you know that they are there, but you don't need them yet. And then you have a typical structure of a Redux application that has a folder for actions that are actions creator. In fact, action folder contains web client actions contains several files, one for each reducer. Usually you have the same name used for actions, and actions related to the same reducer. So for instance, here we have the actions for layers, add group, add layer, and so on, add group, add layer, remove layer, and so on. These are the types, for each type, more or less, you will have an action creator. Sometimes here you can find, in these files, you can find also tanks that will be treated as actions creator. As I said yesterday, you can dispatch actions or tank actions creators or tank, and if the middleware is in, they are automatically distinguished and used accordingly by Redux. You can find this actions directory for layers, and the same name files are for reducers. So if you open the reducers directory, you can find the layers reducer that typically intercepts actions like, for instance, layer load. You can find add layer that gets all the layers, for instance, manage the groups and adds the layer, sort them up and adds the layer to the new list. Basically, it returns the new state with the new layer added to the list. Then you have a directory for components. For instance, the table of content for components that are React components. For instance, the table of contents, that is this plugin, this component. This, for instance, renders a component with class name of this. If you look at, for instance, if you look for this, I can find it inside. Let me try another example. For instance, the toolbar. The toolbar is this one. You can find it here. Oh, sorry, this is the toolbar of the table of contents. Sorry. Yeah. You can find, for instance, let me find out an ID so I can explain you what I mean. Let's use the search bar that we already confident with. We have the search bar input. We have here in the document we have this component. As you can see, there is the search input here as class name, and there is a property called class name passed to the component, and it is joined. This is more or less the same that doing this. It gets the class name and the here you can see that this input is generated by this component. So every component in MapStore, every React component more or less will be rendered as a tag in HTML. You can find them in the application. So actions, reducers, components, then epics that has the same naming conventions. For instance, for layers, you have epics for layers that creates some side effects. For instance, there is an action called refresh layer that updates the layers names and from the server and the bbox and so on. So if you trigger this refresh layers action, you will go into this epic and it will get all the information from the describe feature type or describe when or from get capabilities from the service of the WMS or something, or whatever it is, to get the layer information and update the title and description. Or another example can be in search. We have search actions. We have seen. Search actions. For instance, text text search is changed, the actions that we have seen yesterday. And we have a reducer for that called search. That intercepts this action and updates the search text. And an epics that intercept the text search started in this case, or whatever event to query the services, and this is the multiple service system that queries all the services available, and these intercept the responses and provides the results. This is the epic of the search tool. And this is the structure of every file, more or less. You will find the same naming convention for every part of the state. And most of the time, this part of the state is also part of a specific plugin. In plugins directory, you can find the plugins. Now we'll see what are the plugins. No, sorry, sorry, in the directory plugins, I said. The directory plugins, you can find all the plugins of MapStore. For instance, there is a plugin for login that implements the login tool, or the login tool. This is the plugin for login. A plugin for map that implements the map tool. There is a plugin for catalog that implements the catalog here to browse data and so on. And all the plugins has more or less this shape. They export. There are several ways to export plugins. I'll explain it later when we will develop plugin. Anyway, one of the way to export a plugin is to use this utility function called create plugin with the name of the plugin, and then the component that implements the UI, basically. This is the component. This is connected in line, but anyway, you can imagine that you can do const component, and this is the connect function we have seen yesterday that uses something to get the state and connect it to the real component. And then here you can imagine that it is used here. And then some other properties to include the reducers, epics related to this plugin. So basically, this is the main structure of the directory of MapStore. You can find other directories that contains, for instance, the stories. You don't have to care about them or the product. Examples and so on. There is a directory for translations that contains all the translation files for all the part, for everything. And these files are loaded when you switch language. For instance, when you switch language, this JSON file is loaded. You see that, yes, for instance, if I switch to French, I download the French file, and with all the messages and localization. And this structure contains the main plugins part of the framework. There is another directory called product. That contains the plugin and another similar structure, but contains plugins that are only part of the final product that is deployed here in dev. That is this is the final product. It so contains also the fork me on GitHub plugin or mailing list plugin that are not part of the framework but only part of the for instance, here this is the fork me on GitHub link. This plugin is this, and it's not included in the framework but only in the final product. Okay, and the product plugin contains also the list of the plugins included in the product. There is a plugin.js files that imports all the plugins available in the final product. These are the plugins that are available in the build version of MapStore. Let's see it a little more in detail. What are the plugins and how to handle them and how to include them. We are getting near to the interesting part. The most interesting part is basically as I say, the plugin is the main development unit that you can imagine for MapStore. You can imagine a plugin as in its simplest form as a component. Here I wrote some, I think I typed something wrong. Let me go in history. Just a second. I don't remember. Okay, I can remove it, I think. Anyway, it was a typo. Okay. You can imagine a plugin as a component that is simply rendered in MapStore. Rendered in MapStore UI as it is. For instance, if I create this plugin here, let's call it. I have already here an example plugin, but let me remove it. Let me move for a moment these samples here. Just a second. Okay. So let's create, for instance, a new plugin by including this. This is a simple component. It has a style. It is this is a JSX. It is a simple component that writes hello in a div, and I export it using create plugin utility, declaring the name, and declaring the component it's using. This is a simple thing, a simple hello word for MapStore. You can include it in a new file called in plugin directory. You can create a new file here in plugin web client plugins directory called example. SX. You can simply create this simple component here and include it. There are three things to do in order to include the plugin in MapStore product. And a similar way you can do it in a project or in your you have to include it here. Then you have to create the file. Then include it in the plugin.js index file. There is a plugin.js for each project, and the product is a project, more or less. And so you can open the product plugins.js and include it. Include your new file here by calling using this syntax example and postponing plugin string to the entry, and then including the file. Here I have to write default. I'll explain later why. The three things that I have to do is are to create the file, include it in plugin.js, and include it in web client local config. That is the main configuration file of MapStore. here there is a configuration file with all the settings, and there is a plugins.desktop entry for plugins. There is a plugins entry here where you can find all the plugins for all the pages of MapStore. There is a dedicated entry point for MapStore viewer. The map viewer. The map viewer has 3 different entry points: one for mobile, one for desktop, and one for embedded mode. Now let's concentrate with desktop part, and the only thing that you have to include it here in the list of the plugins in the desktop mode example. The only thing that you have to do is to include the name of the plugin here. So, summarizing 3 things: creating the file in the simplest way. It is a component, and you can use create plugin with the name of the plugin and the component included in this, declared in this way. Adding it to the plugins.js, and then add it in localconfig.js. Let me include another attender. When I do the 3 things, if I save my plugins file, I cannot resolve it. I have another person join. Okay. I wrote something wrong, maybe. Plugins example. I moved it. I put it in the wrong place. I have to move this example from product plugins into plugins. I put it in the wrong place. Now, if I have found it, I include example in plugins example, and then if when the page refreshes, because reloading the code I changed in real time, I can see there is a hello here that you can see. Let's dial it a little bit because I position absolute. I have to put that in that index in order to show it above the map. So as well as I save, the build is done automatically, and so it is refreshed automatically, and you will see that you have the simplest plugin that you can imagine here. So, summarizing, to include a plugin, you have to define it using the create plugin function. You have to include it in plugins.js, and you have to include it in local config, desktop entry point, plugins desktop entry point, and some other details about this procedure. First of all, in MapStore you will find several ways to defining plugins. This is because of the history of MapStore. We have plugins that has been created before there was a convention for exporting plugins before we created this utility. Anyway, for new plugins, we use many times we always use create plugin for new plugins. We will define in the future some procedures and some standard parts in order to well define these standards. And in the future we will add to documentation also, and we will uniform also the other plugins to follow the same convention. But if you explore the framework sometimes you can find plugins, for instance, defined in other ways. For instance, this is another way to export. It's okay to export it in this way. and it's the same of using create plugin. Now we will deprecate this way in favor of a standard way for all the plugins. And other details about that, in MapStore we will find import mixed to require. These are two different strategies to import file from one module to another in JavaScript. One uses require.js, that was a library, and another, the import is a new syntax of ECMAScript. MapStore started when import was not yet standard, so older components as require, and import initially didn't have a way to load modules asynchronously. So for this reason, MapStore used require a lot to import modules from other files or libraries. This is a library imported. If you instead use the path, this is a file imported, a file from local directory. And for this reason, for these two reasons, import was not standard at the moment when we started developing MapStore, and it didn't initially support asynchronous require. We use a lot require here and then in MapStore. In the technical depth of this year, so before the end of the year, probably we will migrate everything to import notation. Anyway, you will find these mixed syntax in importing files. Especially this is problematic for so if you don't know the two systems very well, and you find confusing these default imports and the reason of that. Now I'm going to explain them. Anyway, in the future they will be removed. If you the import and require works cannot work together in the same file, so you cannot mix require and import notation in the same file. But you can import a file or require a file that uses import or require without any problem. So for instance, here I use require and I import a file that uses imports inside. I require a file that uses imports inside. The only problem is that if I use here, typically in import notation, I use export default notation, and if I use this export default, I can import it in another file. I can import this file by doing import my import add group from path to the file, or alternative I have to use require path dot default. This is the only difference. So if a file uses import and exports a default, to import this default, you have to use this syntax in required syntax. For this reason, here we will find a mixed usage of default or not. Typically, every time you see default, the required element uses export default here. You can see that there is an export default here. The file that doesn't use it typically use require. And the required syntax to export is model.export equal something. So all the plugins, all the plugins that doesn't use the import syntax are required this way. The new ones are required this way. These files use typically the import syntax. So every time you use, if you develop new plugins, you will have to use the new syntax. And so in plugins, you will have, until we don't uniform everything, you will have to use the .default notation in order to import it. Otherwise, it will not work. It will give you, if for instance I import this way, I will not see the plugin because it is not present. And I will see a warning, I think, in the
How's the escape zone? Is it the break? Hello?
No, I think it's some kind of connection lost.
Yeah.
Connection.
I think it's connection lost.
Oh, okay, okay.
Are you still there?
Yeah, we are around, but Lorenzo is not around.
I'm Lorenzo. I'm Lorenzo.
Ah.
I joined for
Same ones.
okay. I was kicked off by Zoom. I don't know why. Let's restart. Let me share again the screen. Let me close. Okay, just a second. Let me close everything. Okay, let's restart what I was saying. Okay, so about the syntax, if you find this and if you write new plugins, probably you will have to use default in order to use the new syntax as well until we uniform it. I think in the next release. In the next release, we will replace all requires into plugins into import notation, and this will not be a problem anymore. Anyway, if you try to import this, it will not work. It doesn't find any file about that, and it typically doesn't render nothing, and if you add the default instead, it works. Okay. So we developed the simpler example we can imagine. You can improve our plugin that we created by adding reducers, actions, triggered, and epics using the connect function we we explained in that previous lesson. Now we will see a little bit more in detail. When you connect for instance, we can improve our example. Instead of showing hello, we can use it to show the current zoom level of the map. So for instance, here in the, if you look at the developer tools, I can see that when I change that zoom, this comment button is to clear the current action. If I zoom in, I have a change zoom level action that changes the state of the application in the map and gets the zoom from 5 to 6. In order to get pieces of state, there is another directory in MapStore that has functions that parse the global state and returns the variables we need. This it's a collection of functions called selectors. You can find it here. For each reducer, more or less, you will see a selector, or for each plugin, you will find a selector dedicated to that. For instance, we have a selector for map that for sure provides some selector to get the map. As you can see here, there is a it gets the map dot present. If the history is present, you can ignore the internal using this selector. You can ignore the internal structure of the state and use simply these functions to parse the whole state and get the variables you are interested to. For instance, here I can get, yes, I can try to show instead the current projection of the map. I can use the projection selector or this way. I can use my plugin, and I can use the connect function from React Redux. I can import using this is the sorry team. Here you can use the connect function. This import notation with brackets is similar to, and those also the same of the what we have seen. It was the let me get it. We have seen in the syntax. It was the same that we have seen it with the structuring. It gets a piece of that library or a piece of that exported by this file. Here in Redux you will see an export connect somewhere, export const connect here, and from export const connect you can import it by doing this using this notation. The same for our selector. I can import it by selectors map, and I can use this syntax to get my projection selector from this has been exported. Here you can see that this uses the require syntax because it's an old file, but anyway I can import anyway sub settings without using default in this case. You can, because I'm using import doesn't care about default, is automatic for default. Instead require uses needs the dot default notation to get the export default element. If you export normally, you don't have default to add the dot default. It's a little hard to get into this default notation and mix it with require, but when you get in, you learn how to do it, or at least you can try by error. So I import connect function from Reactor Redux library. I import projection selector from my selectors, and then I can use I can create a connected component, constant connected component, and using connect function, and I can use the connect function has the map state to prop function as the first argument, so I can here I have the global state as argument, and I can use I can return the properties passed to the component by using, for instance, projection equal projection selector applied to the state. This way I get the global state and I extract the using the selector from the state projection. Projection selector is this function that uses that gets from the map the projection, and I can use this component, this connected component. I can use this, apply this enhancer that is created by connect to the component. This is the typical notation you use to connect the component, because let me explain it a little bit. This connect function returns a function. We call this that can be applied to the component. We call this function, this particular functions enhancers. Let's explain it a little bit. Enhancer. I don't remember how to write an answer. Okay, it should be the correct syntax. And then I apply this function to the component. This makes the component aware of the state. And I can use the connect component inside my plugin. This connects the state of the application to the component that normally shows only hello. Now here I have the properties. Passed here, and I can use it, and I can use them in the JSX to display the projection. The current projection of the map is, and I can use props dot. The property projection is here returned by this. This is the map state to props function. I can save it, and I will see the changes on my UI. And if I wrote it correctly, because never say ever. Yes. And you can see that current projection of the map is this. If I switch projection, it automatically changes because it's monitoring the same state point. Let's recap a little bit to understand what we learned or what we tried to learn now. As I said, a plugin can be created by creating a file, and to include it to MapStore, you simply have to add it to the plugins list in the product or project, and then you have to add it to localconfig.js in order to configure the application to use that plugin that is declared here, and the code is included here. At this stage, you can enhance your plugin to do something else that displaying a simple string. And to do so, you have to use a React Redux library that allows to connect the state of Redux with the components. And you can do it using the connect function. Let's repeat the connect function. The connect function has this shape. The easier way is to simply use map state to props. Then we will see. We will try to use the other arguments later. But for the moment, I can simply imagine map state to props as a function that maps the global state to the properties that I have to pass to my component. Then I have to apply the connect to my component in order to connect my component. And this is the shape we used more or less. I can write in the same way here. Map state props. Let's. If you are not confident with this syntax, I can make it more explicit. Can do. It returns an object with the properties to pass, and I can use map state to props in the connected component, and then pass the connected component to the component entry of the plugin. So this is the React component. This is the function that connects the state of Redux and maps it to properties to pass to this component. This is the glue code that connects this state to the component. And after all, we have a component that we can use in our application connected to the state, directly connected to the state. Is it clear? Any question? Did you understood more or less the steps we followed?
Yeah, for me, I really get it. Really, because I once looked at the MapStore source codes.
Okay. Others?
We are okay. For me, it's okay, and I've just followed up the steps of how to create a plugin, but the other sort of connecting, somehow the concept will become clear when I do it practically.
Yes, the connect function. I think the most difficult thing is to understand is the connect function returns a function that have to be applied to a component to connect it. When you get in the mind into this functional way of programming, it's easier to understand because this is, I think, the most obscure part. Other than this, it's only the only thing that we did more than the standard example of Redux is to use a selector that is already present, a function already present to select some pieces of the state and don't care about anything else. Connect function has another argument that is map dispatch to props that allow to automatically map some actions creator in order to dispatch some actions. This is very useful if you want to dispatch sections from the user interface. This is the way we do it. For instance, we can add the button here. To zoom in. And we can add the handler. And I forgot. I didn't put the projection here. I forgot to edit the history. Anyway, let's do it. Let's do it again. Now I recreate. I hope I recreated the previous plugin we did. Yes. Here, if I switch, I have the change maps CRS that change the projection, and of course you will see the new projection here. Switch. I added this new button here, and I want to dispatch an action that zooms in in this component. Let's see the actions of the map that provides a zoom. Map. Probably they are in the map. There is a change zoom level action. So you have to get the current zoom level and increment by 1 in order to change the zoom level. I can use this change zoom level action here and add it as a second argument. The most easier way to use map dispatch to prop, the second argument of connect that allows to dispatch actions, is to pass an object with the actions that you have. I can import it from actions map. I used the wrong syntax. Oh, sorry again. Nope. Now I imported here, and I adding this part to the adding the second argument to the connect makes the properties contain also this entry other than this. Allow to contain also this property that is a function to call in order to trigger the action. Here I have to zoom in, and so instead of here I can create another function that on click calls the change props dot change on level, and here I have to put zoom level. For instance, let's put a constant just to try it, and let's call the button to zoom level 1. And let's wait. So if I click here, you will see that change zoom level is triggered. The action contains zoom 1, and the state changed to zoom to 1, level 1. Now we have to get in order to increment or decrement and emulate these two buttons functionality in our context, just as an exercise. We need also the zoom level, the current zoom level of the map. I can use another selector from here. Select. Sorry. Selectors map. This one. I don't see a predefined selector for zoom, but I can use the map selector and then use the zoom. I can create even my own selector in my plugin or in my selector file anyway. Let's create it just to try to understand also how to create a selector on our own using other selectors. For instance, here I can create a zoom selector. Here I can extract map state, and then I can return. Here this is the optional chaining that allow me to not having error if map state for some reason is undefined. And the map selector is from here. I can include it from here. Here I have the zoom selector. So here in the map props, I can add the current zoom using the zoom selector on the state. And then I have another property called current zoom here. And I can add the button here. For instance, I can add the two buttons called zoom in and not where use current zoom plus 1 and more zoom out with the current zoom -1 properties.current zoom. So summarizing, I used the same handler to change the zoom level and reuse a part of the state, especially the current zoom part of the state, to increment and decrement the zoom level. So now our plugin should be able to zoom in and zoom out and show the current projection. So now we are using the state of the application by itself, but we can create the state for our own for our plugin. For instance, here I can add to this plugin that is a toolbox. It's becoming a toolbox of various things. I can add to this input box, a text area to take notes. I don't remember exactly what if text area is a value because it's a lot of it's a very long time I didn't use it. Text area, yes, it uses value, and I can now I can write something here and this stays, but I cannot. It is not present in the state. I can use a reducer for that. This is because of the input. Normally, the state here is not performed. For instance, if I have a counter, let's use a counter because it's clearer for this way. Let's imagine that instead of taking notes, we have a button. Let's create another div with a button for increment counter. And a counter value. Okay. Now I cannot increment the counter yet because I don't persist this state, and so I cannot increment anything. In order to do so, we have to create our own custom reducer. We can use the internal state of React somehow. You can use, in particular, you can switch to the explicit way of creating a module, creating the arrow function that implements the component, and I can use one functionality from React that is called use state here, and I can use a local state here to this is a particular thing of React. Count, set count. And I can use this variable to increment our counter. This is the React way of keeping the state in the UI, but this way this way is limited to the React component. It is not part of the global state, so you cannot share the state with the other components and or with epics and so on. So it depends from what you need. If you only need a local state, this is a no. And that's something that I did wrong. Let's see what the console tells to me. Mm. I used it exactly as it's required by. Let me see what's there or what's the problem. Yes, here. Yes, probably I. React does not recognize. So these are some warnings explained as errors by React anyway. They are warnings. The real error is only this. And honestly, I don't know what I did to to create this error. It's the first time I see it. Let's see if. Okay, what I did is I understand now. Instead of passing the function, I called it directly in the here. The correct syntax is this because this is the handler that have to be called. So this function have to be called when you click. Doing this, I called it and returned the value here, and it was not the correct usage. This is the correct one. Now it works. As you can see here, I can increment the counter, and this is the local state of the component instead itself. It is the map component. The React way of keeping state inside. But if you want to share the state between components, between applications, and so on, you have to use the the reducer. To do that, we can create a reducer in the reducer directory and a connection that triggers. Instead, what we can do here is to convert this into a reducer. And actions, and the state can be created in the reducer. This is only an example to explain how to create, of course, reducers and so on. So I created a new file, reducer web client reducer directory, called example, and I can create a reducer that simply and an action file in the actions directory with the same name. Call it actions. I call it example, and I can create the action. Typically, we use the action type to define the action type X as constants at the beginning. Increment. Another convention that we use is to prepend the type with a string that identifies the plugin or the piece of state interested. Example. In order to avoid an increment counter, another increment counter action named somewhere else in some other files. This is the action type, then I can export also the action creator. This simply returns an action with type. Okay. So here we have an action. We can create a reducer. Reducer is a function that has an initial state. Let's see that the counter is equal to 0 in the initial state, and then it gets the action. Then typically it has a switch case. The action.type that parses the type and intercepts it. Now we are interested to return the old state in all the other cases, and only use increment counter that can be imported by the actions file. I imported the record. There is another action file called example. Okay, I've seen it. Yeah, this one. Okay. Here I modify the old state. I return a new state. Incremented. And this action together with the reducer implement the logic to increment and decrement the counter. Let's see what are the syntax errors here. Okay, expect the return the value, return. Break is not important here and there. Here okay, now the syntax is okay. This action and this reducer implements the logic of incrementing the counter. So I can use this instead of using set count. I can use props.increment counter here. It only increments. The logic is implemented there. I can call it counter here. Now I get the variable that was local Now I get them from the properties. I create another selector to get the counter. State.example.counter. This is an important part. Let's see it. Here I can declare in plugin the reducers. Using this syntax, I can declare reducers and then the name of the reducer, example, and I can get a function. This name is the name that will be assigned to the slice of the state implemented by this reducer. So declaring the reducers in the plugin reducers allow to add pieces of state to the whole application. So you can add this piece of the state implemented by this reducer, and here we can see for the moment this syntax in the creation plugin allows to add the piece of state managed by this reducer to the global state. And this is the name of the piece of state. So now when we do this somewhere in the code, we will be able to access that piece of state simply by the same name. I can use the optional chaining in order to avoid possible errors. I cannot resolve actions. I don't know where I imported. I can remove this. In example actions, I don't know why I imported. Let's see what is okay. Let's fix the syntax and the path solving. Chance example. Resolve lips Ajax that is not present. Yeah, probably. I had an old file here, and I renamed it, and I did some changes, and so Webpack didn't recognize that I renamed this one, and I was using this one. So in this case, you have to, because it was trying to get lib Ajax that is present here, but not here. So in this case, restarting web dev server is more than enough. Now it will work. It will work. If we finished this example, I will explain you how to. I will use the other example I created in order to explain you how to do, for instance, some Ajax requests, and we in this way we can complete more or less how to develop a plugin section. And tomorrow I suggest to continue with the project part. That is a small piece of this training, and that is important also for the Genode part. But I'd like to give you more as much as examples and repeat the procedure of creating actions, reducer, and so on as much as possible in order to let you get inside the system and understand how to develop and do things. So at the moment, I didn't connected the action yet. So probably I will see only the count. I can connect the increment count, or I did it yet. you already did it. Increment counter here should be connected here. And it have to be imported from actions.example. Again, I did. Again, same problem. Okay, probably the naming JS2 is not let's restart it again. While he's building again, I'll explain a little bit more other parts. Other than component, as I said, you can include the reducers here by declaring they are included automatically in the state. Then you can include the epics you want to use. If you include them here, they are part of the system, and so they will intercept and emit actions. And you can declare also containers because in some cases there are plugins that are plugins container and are able to contain other parts of the plugins. This is the case of this menu, for instance. The typical in these plugins, typically the component is the main panel. The component you declare here is the main panel, and then there are some declaration about again there are some declaration about the, how to include insert in other plugins some entry points in order, for instance, to add an entry to this menu or something like that. This is probably a simple, yes, probably there is, okay, maybe I can imagine that. Okay. But here there is a reducer. I have to rename this too. Let's see one for example. The catalog we have seen, it's very big as a plugin, but anyway, it is called, let's see, for instance, just it has a bad name, but anyway, this is the catalog, and it has, as you can see, many entry points like these. These are the containers. This is the other syntax defining the containers, and allow to insert some entries here and there. I hope this compiling runs. Otherwise, I think I have to switch to the next part. Okay, now it didn't work yet. I don't know. I don't. Probably it's a stupid thing. MapStore 2 example actions. It's importing the wrong file. Example actions example. Yes, there is some mixing between the actions that I created here, and there are some conflicts with the names. Probably example actions. Hmm. Ah, okay. And where it is? This is imported. I imported in errors this file somewhere, and this file was a thing that can remove because it was an old directory, and now it works. Or at least it will not resolve the file that I imported, and I can. Okay, it was probably an error I did. I imported it in plugin. Yes. Yes, this is the problem. Instead of importing the correct this, I imported this one. Okay, now it should work. Sorry for the mistake, but I forgot that I had that directory example with some files, some old files from a previous training or something like that that I collected. Now the build will work. Yes, now it's working. Let's see again the map. Let's reopen the new map just to, sorry. Now it's not connected, but at least it compiles. Okay. Now let's see what happened. Let's check how did I did it. Current counter state.example.counter. Let's see if the global states contains the example state first. And let's see if increment counter triggers correctly the action, and it works. But the state doesn't change, and the state doesn't seems to contain it. So I think that I imported it wrong in the wrong way. Reducers. Maybe I wrote the wrong reducer here. Export default. Okay. If you export one single file, you export in the export import syntax has this rule. If you export a constant in example somewhere else, you have to import example. If you export default, you can import example like this, or if you need to do require, you have to use dot default. I repeat it again, even to me. So as well I do export default. I can see example, you can see it in the reducers with counter equal to zero, and as well as I click here, I increment the counter. You can see that every time the counter is increased. Now I should explain you in the last half hour how to do Ajax requests in order to have more plugins that are more useful on the client side, because you can do it with funcs or you can do it with epics. Here I had a predefined example, but let's do it together. Now our example allow to increment the counter, to zoom in or zoom out. Now let's get some data from the server. In the server we have a version.txt file that contains the current version of MapStore. We will ask for this file remotely in order to get some data from the server. Okay. And so let's add another section to our plugin. Let's name it now this version.txt contains simply a string like this, but in production it will contain the effective version of MapStore. Let's create a button that on click ask for the version. And then let's add another if props for dot version is present, then I'll show this string. Otherwise, let's do it. This is a ternary operation. Otherwise, no version. Now I have this section. So it was a counter. Let's divide it in. Prefer to divide our plugin in different sections. Style. Just to have a small padding for the div, just to don't have these bad borders. Okay. Now we have to trigger an action that retrieves the data from the server and write the version here in the state. So we have to create an action that we can use a thank for this way, for this request, and we can create it here. Here, increment version can be, the ask for version can be passed here. I don't know why, but there is a bad syntax thing here.
I think the symbol that you used is, I mean, for the characters, version
Sorry?
is the one that you used to post version,
Yes.
double quote and single quotes. Is it the same as double quote, single quote? That's one. It's not the quote. Yes.
It's not this one?
There's a single quote. You put a single quote, but that's like what's the name of it?
Yeah, something.
Go. I mean, this next version. Version is before that. That's a quote you use.
Ah, okay.
Yeah.
This yes, this is the syntax. Okay, I can use the normal syntax and see what it can do.
Still
Something like this would work. Sorry, probably this is not present. It doesn't like it anyway. I don't know.
Yes. How about the question mark from the?
Okay. Anyway, it's only a problem of highlighting. Let's, for instance, we can simplify this by doing this and nothing more. Honestly, I don't care for the moment. If I remove this, probably it will be visible. It seems like something related to this button or something similar. If I remove it, yes. If I remove this close button tag, everything will go fine. Not sure. Probably this. Yes. Okay. The syntax highlighting tool doesn't like so much this at this point. Okay. Let's continue. And now I can paste here the ask for version. I can add create a new action creator that is a thank that is called action creator and pass it to the connect function. I import it from here and I will create it here. A thank, we said the last time, it's an epic that returns a function. An action creator that instead of returning an object returns a function. I can return even an arrow function with dispatch, and we can create another action creator. Set version here that sets the version in the state, and I type here. The score. This is the effective action that will update the state of the application after receiving data from the server. So these have to be intercepted here from the reducer. So can you add the new case? Here in this way, I copy the old state, the old state, and update only the entries that I'm interested to. For instance, I can use add the version to the state with action dot version. So doing this, when I trigger this action, the version is passed to the reducer, and the state is updated. And the state is updated with another entry version here, and I can pass it to the component. Okay, so as well as the tank will call this action, it will update the state in the reducer, and this is connected to the plugin, and it will show the version. So the only thing remaining to do is to use Access. Here we have in MapStore we have customization of Access available at this libs Ajax directory. Can name it Access because it's the same. That has some special things, special customization in order to automatically use the proxy if the request is out of the current domain, and to include the authentication where needed. So in all the Ajax all the Ajax requests are done using this tool in order to add the proper authentication if needed there, and this is not the case, but anyway, we usually use that version of Access that is Access plus some features in every point of the application to be uniform and support any kind of authentication if needed, even in the future for your application. Anyway, Access can provides a get method that you can add the URL of the service you want to invoke. In this case, this is a simple static file on the server, and then it returns a promise, so you can get a response from this promise and dispatch the action set version with the version. I don't remember exactly if the response, probably here you have a response.data or something like that. Access provides in data the body of the response, while other here you can find other information like headers and so on. Let's see if it worked. Yes. Let's see what happens when I click on the button. When I click on the button, I put a breakpoint here, so you can see this function is called, and automatically Redux recognizes that this returns a function, so it will call it and will pass dispatch function in order to dispatch. The calling this function will trigger the access request, and the access request will trigger a request to the server. You can see that I'm getting the file from the server. This is the content, and the content then is triggered in another action here in Redux at the end. Example, and this action triggered example set version contains this string, and this string is updates the state in the reducer, and because this part is connected, it will be shown here. We can do, of course, the same with epics. In this case, we have ask for version will be a simple action like this. For instance, will be a simple action like this. Ask for version. No parameters in this case, and you have to create an epic, create a new epic file here. And import in the export ask version something X for version. It have to be imported here. I didn't exported it yet. I didn't save it. This is not needed anymore. It's needed here. I can implicitly I use the fair to create a request, as I said in the previous meeting, and then .map In this way, I create a stream coming from the promise here, and here I map every event emitted from this stream to create another event emitting an event that is the action with the version name. So here map, I have the response here, and so I have the response dot data, that is the version. I have to declare, I import the epics here. In the same way, I can declare the epics here. And I hope it works because I did it very quickly. But basically, the difference between the tank version is that in this case, we created a simple action here just to be intercepted by the epic. The epic does the request and emits the action, the new action that for the response. And it doesn't work. And let's refresh and see. This epic should emit the set version as well as it receives a response. Let's see what happens if the epic, for instance, is triggered. The request doesn't seem to be. Yes, I missed this. Okay, switch. This is a little not too much understandable, but let me make it more explicit. Okay. Yes, now this is triggered. The version is called, but the action is not. The new action to set version is not emitted. Okay. So here create a stream, and as well let's do a switch map just for case. Yes, because if I use map to, I can use these. Okay. I had to use it. I can use both, but let's decide to use one. Anyway, these operators you will get confident with them as well as you start working with them. But anyway, here I do a switch map as well as I receive this action. I create another stream that creates. I create this new stream. This new stream do the request, and then it creates a new stream that emits an action that emits an action. You can do it this way, or you can do it using map2 and doing simply this. If I remember well, map. Sorry, not map2, and the response in this case, you can return directly the action instead of using another stream. But the effect is the same. Here I create a two stream in cascade and I flatten all the events emitted from this stream onto the final emission stream. And in this case, I will see that the action is emitted. This is of course more complicated, but it helps a lot to do some useful on the operation in a simple way. For instance, if a user starts to click repetitively on this button, I don't want to do thousands of requests. Okay, if I start to click a lot of time here, every time I have a request, maybe I don't want it. And here I can see, I can do the bounce, use an operator that waits, for instance, half second before to trigger the final event, to trigger the final request. So in this case, if you see I'm clicking, but it's not doing the request until the bounce time is the correct, if I remember well. Yes, if I click a lot on this button, nothing happens until I stop for half a second. Then I can start again to click in compulsively, and nothing happens until this half second is passed. This is only one example. You can use even switch map to download it using a timer or something like that, and it's very flexible in terms of for this simple example. Of course, doesn't care too much using tanks or epics, and tanks are more simpler. But if you have to do or cancel requests, for instance, if you have to do operation that depends on the current viewport or depends on the complex user interactions, this is very useful to simplify the code and make it more maintainable. And that's all for plugin development. I hope it helped. I hope to not kill anyone. I didn't kill anyone. Bored to death. And any questions?
Yeah, I'm glad you are live.
Keep on, Edgar.
Someone is dead. Okay.
No, actually I'm alive. You have not killed me, but I just wanted to confirm one thing.
Yes.
I saw how you were passing reducers and epics. Maybe if you can open the source code again. I just want to confirm, because I've seen you are accessing the state directory without selector. So I wanted to confirm, if you are creating a plugin, do you have to access the state directory, or you can also create your own selector and inject it somewhere?
Okay. Here I created selectors in line. This is the question. Can you repeat a little bit, because I didn't get some points.
So can we go to? Do you see the way you passed the reducer?
The reducer. The layers reducer. Sorry, what reducer?
Yeah, the example reducer.
Yes, here.
In the connect.
Yes. in the connect. Yes, I understand. Here you can create. I didn't create the file for selector to be quickly, but you can create a separate file. It's not mandatory, but if you want to collect all your selectors, it's a good practice to do that. We do it regularly with our plugins. If you don't want in your own application, it's not mandatory. If you probably it's useful to do an example JS selector that contains, for instance, this version selector. And the here and the counter selector here. You can do this. It's more easy to understand what are the interesting point of the reducer. Isolating selector here helps to get the important points of the solution and creates a sort of interface to access into the Redux state that otherwise is an object without any structure in particular, and this gives somehow an API to access to it. And having actions allow to be a sort of setter for the reducer state, and the selector is sort of getter. In this way, you have an interface to set and get values in and from the reducer state. Isolating selectors and actions helps to isolate the interface where how to interact with the application state created by the reducer. I hope I replied your question.
Yes, yes.
Okay. Other questions?
Mine is just a comment. If possible, can you send us some of those slides? At least we can get through before we have the lecture tomorrow.
Can send, sorry, this example?
Yeah, those examples were those PowerPoint presentations.
Okay.
So you can review them before have a class tomorrow, if it is possible.
Okay. Send presentation and a zip with the example we developed. Okay.
Yes.
Yeah, me.
Okay.
I don't have any. I don't have a question. I think Gideon copied my mind for now because I have something that I want to tell you.
Mm-hmm.
And it is better to send us maybe by today because tomorrow we are going to finish this. And at least if you have a question, we can ask by tomorrow.
Okay, fine.
For this codes and PPT, yeah.
Yes, tomorrow the tutorial for Geonode is not that big because you now have all the instruments to understand it. I'll not explain Python code because I'm not the best person to do it. So I'll reserve before and after the training question time. Okay, it's okay for you.
Pardon?
It's okay to us. It's okay.
Okay, fine. So I'll send you these files, the required file, and I'll and see you tomorrow.
Okay, thank you.
Okay, thank you too.
Yeah,
I hope
thank you.
it helped. It was hard today to follow this presentation.
It
Not
was so
much.
good.
Yeah.
Okay.
Yeah, because
Okay.
we saw it practically. So I think by elaboration and how it has been implemented within the how we view with the map, something at least we know practically how it is and how the files are organized and how we can develop the plugins. The other part of the concept, it needs a little bit of time to actually understand them and actually put them into practice.
Yes.
But at least we know the structure and how to work around those structures. Then tomorrow we see how we can work with GeoNode and see how it has been structured or inserted or injected within the GeoNode. Then we can have a clear picture because most of us were working with GeoNode. Then we can see how it has been integrated within the GeoNode. Then we have full understanding of those. And the other part, I think it will take some time. I hope my colleagues do agree with me with that.
Okay. Okay. So yes, I gave you a lot of information. So even the time to elaborate it should be nice. So having all the training session one against the other makes difficult to digest concepts, but they are not fresh. Tomorrow we will see, as you said, general part and everything should be at place. Okay, so see you tomorrow.
Stop. This meeting is.
Thank you.
See you tomorrow.
Yes,
Bye
see you
bye.
tomorrow. Thank you.
Thank you, Lorenzo.
Bye bye.
Bye bye.
Bye.